How about 2 bar? At 2 bar, all of the ASA samples, including those smooth with acetone, took on a significant amount of water. Let's start the testing at 2 bar to see if Bricklayers can improve the waterproofness any further. I'm going to use ASA together with a 3mm hull thickness, random seams, and no change to the standard extrusion flow multiplier, together with stagger perimeters enabled, aka Bricklayers. So the dry test hull weighs in at 97 grams. Let's set up the test rig and get testing. Now let's add some pressure, and we're off. Let's take out the hull. Oh dear, can you hear the ominous slushing noise? Let's do the weigh-in. Okay, it looks like it's taken on only 3 grams of water, which is about 10% as much as the best uncoated sample I tested last time. How exciting is that? Something that Stefan from CNC Kitchen covers really nicely in his Bricklayers strength testing video is that because Bricklayers can pack more efficiently, you really need to increase the extrusion flow multiplier in the internal perimeters to take up the space between the shells to maximize the contact surface and print fill factor in this region. So let's see if increasing the extrusion multiplier for the internal perimeter layers that Bricklayers are printed in has any effect. I'm going to try a 1.05 multiplier and a 1.1 multiplier. Let's get them printed and on to testing.
I think another completely dry one.
How about the weigh-in? Wow, both of these prints have remained completely waterproof at 2 bar with no measurable mass gain. What a fantastic result. Let's raise the pressure to 4 bar and see if Bricklayers can compete with epoxy coating the hull, which was the only test hull that remained waterproof at 4 bar last time. Again, no sign of any water slushing in either sample. And after the weigh-in, oh wow, again no change in mass. So again, they're both completely waterproof at 4 bar of pressure, equivalent to 40 meters of water depth. That is fantastic. For completeness, I'm also going to test a sample without Bricklayers that has got the 1.1 times extrusion multiplier for the internal layers. 2 bar, this performed as well as the Bricklayer version, which is a bit disappointing, but at 4 bar, it took on about 1 to 2 milliliters of water, demonstrably showing that adding Bricklayers can improve the waterproofness of a 3D print, and it can also do so without the detrimental effects that go hand in hand with when you simply increase the extrusion multiplier on a 3D print, such as dimensional accuracy and increased printing failures due to the nozzle dragging on the surface of the print. I wanted to end with an illustration of just how much force 40 meters of water pressure is exerting on the hull by testing a slimmed down 1.2mm hull in the test rig at 4 bar. Here we go. It didn't stand a chance. Now again in 10 times slow motion. You can see quite clearly how the hull buckles and fails in multiple regions in less than 1/10 of a second.